In this video, I am going to go over matrices and what a matrix is and how to write an augmented matrix. So a matrix is a rectangular arrangement of numbers, and each number inside the matrix is called an entry. We measure it in rows by columns. So whenever I'm giving a matrix size, it always counts the rows first. So how many across it's going horizontally, and then by columns, which is how many vertical sections there are. They can be named by their position, so by default we just, like, if my matrix name was A, then my first position is A11, first row, first column. Over here, A12, first row, second column. So that's how we use this notation to denote where in the matrix a specific point is. So that'll be more useful in tomorrow's notes, but that's basically what a matrix is. My first 5 examples want me to determine the dimension of the matrix. So the way I do this is, like I highlighted up above, I want to write the number of rows with the letter X times columns. This X does not mean multiplication. It's more of like when we are in geometry and we're doing area, and I use that X to represent by. So I'm going to say it's a certain number of rows by a certain number of columns. So if I take a look at number 1, I have 1 row, 1 column. That's all I have to do here, is I just have to give the size. Same thing for number 2. I have 1 row, because there is one thing going across, and there are 1, 2, 3, 4 columns. So my size or dimension of this matrix is 1 by 4. Over here, I have 2 rows and 2 columns. Right now, I don't care about what's inside these matrices. I just care about their sizes. Matrices are kind of cool because they are used for all sorts of things in the digital world. And I know I took a class in cryptography, and they talked about how matrices are used to display images on a screen and take photos digitally. So that's kind of cool. Over here, I have 1, 2, 3 rows, 1, 2 columns, and right here, I have 1, 2, 3 rows, 1 column. Okay. So what I want you guys to do is pause the video, take a few minutes to work on number 6 on your own, and then compare with people around you, and then when you've got the answer, just hit play, and then I will work it out. So on number 6, I have 1, 2 rows. I have 1, 2, 3 columns. Moving on, I can use matrices to solve systems of equations. So if you didn't like doing those by hand, you might still have to do some of them by hand, but depending on what I ask you on the question to show your method. But if I don't specify a method, so something like on the final, where I will give you a system of equations, but I might not say a final because it's multiple choice. I might not say a method because it's multiple choice. You can use matrices to type in the calculator and solve. So what this is called is, when I'm turning a systems of equations into a matrix, I am basically taking all of my coefficients and the answer and putting it all together in one giant matrix. So if I look, my original system is x minus 4y plus 3z equals 5. Each equation is a row, so I should point that out. So if I look at my augmented matrix, my coefficients match up: 1, negative 4, positive 3, and then the answer is 5. Each column is a coefficient or the constant. So remember, a constant is the number at the end of the equation without a variable. So if I looked at this, my coefficient here is 1, negative 1, 2, 1, negative 1, 2. Over here with my y's, I have -4, +3, -4. Oh, wait. If I look even closer, though, that -4 is not a y. There is no y in my last equation. So it actually goes -4, 3, 0, because there's no y. Then my z's are 3, -1, -4. 3, -1, -4. My constants, my numbers at the end are 5, -3, 6, 5, -3, 6. And then there's another type of matrix. We won't use it in this class, but if you go ahead and go on to linear algebra, you will. It is called a coefficient matrix, which is just the numbers in front of the variables. And this is used when I am trying to solve for a specific variable in the system. And typically you will break up your answers into a different matrix. On number 7, it just wants me to write the augmented matrix and then give the dimension of the augmented matrix. So if I look closely, I have 3 variables, so I need to have 3 columns. What I'm actually going to do before I get started on writing my matrix is I'm going to write this out so all of my equations have all 3 variables, so I don't forget the ones that I need to write 0 for. So my letters in these 3 systems are x, y, and z. I'm going to have x plus 3y. There is no z in my first equation, equals 9. I have no x, so I'm going to write 0x minus y plus 4z equals -2. Then in my third equation, there's no y, so I'm going to write my x plus 0y minus 5z equals 0. Then I want to go ahead and set up my augmented matrix. So this is just taking the coefficients. I have 1, 3, 0, 9. Then I have 0, -1, 4, -2. Then in my final equation, I have 1, 0, -5, 0. And this is my augmented matrix. Typically, I will have a dotted line going down separating my coefficients from my answers. So this is the matrix. Now I need to give the size. I have 1, 2, 3 rows and 1, 2, 3, 4 columns. So tomorrow in our notes we will be solving using these augmented matrices, but today we're just practicing getting them. So take a few minutes, work on number 8, and then play the video when you are ready to check your answer. So over here in number 8, it actually gives me all of my variables, so that's pretty nice. All equations have all 3 variables, so I just need to practice putting them in the matrix. My first system is 1, 1, 1, 2. Then in my second equation, I have 2, -1, 3, -1. 2, -1, 3, -1. And my final one, I have -1, 2, -1, 4. So now that I have my matrix, I just need to give the size. I have 1, 2, 3 rows, and I have 1, 2, 3, 4 columns. And I am done with number 8.